Hello everyone, welcome to Solve It Academy. So one who is watching this video will be expert in the types of relations of both classes 11th and 12th in upcoming few minutes. So let us start the class, okay? So in 11th class we have types of relations, that is one to one, one to many to one, many to many to one. Okay. So many to one is repeated two times. We will cancel this many to one as this is AI generated picture. Okay, many to one. Okay, done. Let us take an example for one to one function. For one to one, let us take the names of the players of the cricketers. Cricketers name Virat Kohli, MS Dhoni, and Vaibhav Suryavanshi. I am taking these three names here. Let this be R1 and the set 2 be RCB, CSK and RR, and this be set 2 R2. So here, okay, a relation R is defined such that R1 to R2, R1 to R2, cricketers, sorry, yeah, cricketers of the cricket team. What do you mean by this thing? I can only map the R1 elements with R2 elements only if they are the cricketers of that teams. Virat Kohli is the player of RCB. I can take him. MS Dhoni is player of CSK. I can map CSK and MS Dhoni. Is Vaibhav Suryavanshi the player of Rajasthan Royals RR? Yes. Then here we can see that only one element of this thing, one element of R1 is mapping with one element of R2. Is Virat Kohli mapping with CSK? No, because the this thing is here. Okay, condition is been not suiting, so will not take that. So this is a one to one. So we can see the definition also here. One element of A is related to two elements of B, and one element of A is related to one element of B. It is wrong. Okay. One element of A is related to one element of B, and one element of B must be related to one element of A. Here you can see 1 to 1. One element must be related to one element. This example is wrong. Don't take it. Okay. One to many. If I am taking here in this set itself, I am including some more things here. World. World means Indian cricket team. Okay. If I am including Indian cricket team, then Virat Kohli will match this also. Then it is for one too many. Virat Kohli is mapping for RCB also, and Virat Kohli is mapping for world also. Is this clear? So this is the thing of one too many. Next is many to one. Many to one. If I am including any other player of world, Indian, let us take the name as X, then I can map this thing also with many to one. Why many to one? Many elements of this thing are being related to this thing. Okay, relation to many to many, many to many. I think you will get the things clear. Okay, many to many and all. So this is not that important. I'll also write here, not much important. Not much important. So the next thing that is 12th board. I am moving to 12th board now. For class 12th, what we will be learning is very important for all competitive and board examinations. Let us start it. First is null empty void relation. Null relation I will take. Null empty void relation. Null empty void relation means what here? A relation from R to R defined. A relation R is called so if no order pair satisfies the given relation. No order pair satisfy the given relation. No order pair satisfy the given relation. See, if I am taking two sets, Virat Kohli, MS Dhoni. This is one R1, set of R1, and I want to relate it with this thing, Indian, not Indian, GT, and one more is RR. Can I relate these two? And the same thing implies, which I had took for last example, no relation is only not there between these two. Then it is called null relation. Null relation. Identity relation. Identity relation. Identity relation is the relation R is called identity if each element of set A is related to itself only. If each element of set A is related to itself only. If I am taking 1, 2, 3 and relation R to R defined such that a relation from R to R a relation from R to R defined such that x is equal to x. X is equals to x means the relation is like this. It is defined like this: 1 to 1, 2 to 2, 3 to 3. This is relation, identity relation. If it is related to itself only, if set A is related to itself only, set A is related to itself only. It is related to itself only. You can see here. Okay. Next is universal relation. What is universal relation? A relation R is called universal relation if R is equals to A cross B. If relation R is equals to A cross B, then it is called universal relation. Not much important. Okay. Next, most important, reflexive relation. Reflexive relation. Very important. In reflexive relation, what we will see, a relation R is called reflexive if each element of set A is related to itself. If each element of set A is related to itself. Each element of set A is related to itself, and other elements can also relate in reflexive relation. Let my set A be like this: 1, 2, 3. Let R be relation 1, 1, 2, 2, 3, 3. R2 be relation 1, 1, 2, 2, 3, 3, 3, 2, not 3, 2. Yeah. 2, 3. This is relation 1 and relation 2. Relation 1 and relation 2. Now, is relation 1 identity relation? Identity relation. Yes, each element of A is related to itself. Yes, it is identity. Is it is reflexive relation? What is reflexive relation? A relation R is called reflexive if each element of set A is related to itself. Yes, this is also reflexive. It is reflexive and identity both. But in relation to, yes, is it identity? What is the condition for identity? A relation R is called identity if each element of set A is related to itself only. Yes, each element of set is related to itself only matters here. Only no other order pairs are required for this thing. Therefore it is not identity matrix. Is it reflexive? Not matrix, sorry. Is it identity relation to is identity relation? No. Is relation to reflexive relation? Yes. Why it is reflexive relation? A reflexive relation is a relation if each element of set A is related to itself. That's it. Not only. Okay. Next, number of reflexive relations. Number of reflexive relations formula very important. 2 to the power of n square minus n. 2 to the power of n square minus n, very important. Next comes symmetric relation, very important. Symmetric relation is also. See, in symmetric relation, what is a relation R is called symmetric relation. If A comma B belongs to R, then B comma A must also belong to R. Again I'll explain with an example. If R1 is relation 1 comma 1, 2 comma 2, 3 comma 3, and set A, it is defined on set A 1 2 3. Okay, like this. 3 comma 3, 4 not 4, 4 is not there only, 2 comma 3, 3 comma 2. Is this identity relation? Revision. Okay, is this identity relation? Is this identity? No, it is not identity, because other elements are also present. Is this reflexive relation? Yes, it is reflexive relation. Is this symmetric relation? What is symmetric relation? Again, a relation is called symmetric if A comma B belongs to R. If A comma B belongs to R, then B comma A must also belong to R. This is symmetric relation. Is A comma B is present, B comma is also present, then it is symmetric. What about these three things? Yes, 1 comma 1 is present, 1 comma 1 is also present simultaneously. Therefore it is a symmetric relation. Relation to 1 comma 2, 2 comma 1, 3 comma 3, 4 comma 2. Is this symmetric relation? 1 comma 2 is present, 2 comma 1 is also present, 3 comma 3, 4 comma 2, 2 comma 4 is not present. So it is not symmetric. Is this clear? Very important. Number of symmetric relations. Number of symmetric relations is equals to 2 to the power of n square plus n by 2. 2 to the power of n square plus n by 2. Number of symmetric relations 2 to the power of n square plus n by 2. Very important. 2 to the power of n square plus n by 2. Next comes your anti-symmetric relation. This relation is a bit confusing. Please do concentrate for some more minutes. A relation R is called antisymmetric if A comma B belongs to R, then B comma A must not belong to R. A is not equal to B. A is not equal to B only for this relation. This one. Now one more thing. If A comma B belong to R, then B comma A can belong to R if A is equal to B. This is different relation. These both are conditions for antisymmetric relation. I will take an example if you are not getting it. Okay. If relation A is defined on A, relation R is defined on A, and A is equals to 1, 2, 3, 4. Relation R1 is equals to 2, 2, 3, 3, 1, 2, 2, 1. Relation R2 is equals to 2, 2, 3, 3, 1, 2, and 1, 3. Concentrate here please. Here we have 2, 2 and 3, 3. What was our condition? If A, B belongs to R, then B, A belongs to R. If A equal to B, is A equal to B? Yes. Now 1, 2. What was my first condition? If A, B belongs to relation, then B, A also must not belong to relation when A is not equal to B. Here A is not equal to B, but A, B is also present and B, A is also present. So this is not your antisymmetric relation. Not antisymmetric relation. Here 2, 2 is there, yes. 3, 3, yes. It is acceptable for antisymmetric relation. 1, 2 is 2, 1 there? No, 2, 1 is not there. Then it is acceptable. 1, 3 is 3, 1 is there? No, then it is acceptable. Then it is a antisymmetric relation. Okay. Is this clear? Very important antisymmetric relation. Next is most important transitive relation. This is also very important. What is a transitive relation? A relation R is called transitive if A, B belongs to R and B, C belongs to R, then A, C must also belongs to R. See here, just concentrate. A, B is belong to the relation and B, C is also belong to the relation. Then A, C must belong to relation. Is this clear? Are you getting? By the definitions we have to understand those things. Okay, these are the mathematical definitions. Clear? Then let us take an example. Relation R1 is equals to, defined for set A, 1, 2, 3. 1, 2, 2, 3, 3, 1. Is this a transitive relation? Let us check it. This is A, B. This is B, C. And this is A, sorry. What is this? C, A. Is this a transitive? No, it is not transitive. It will be transitive if this element is 1, 3. Okay, it will be transitive. Let us take a relation R2. 2, 1, 1, 2, 2, 2. Is this transitive? Yes, it is transitive. Okay. This was about transitive relation. And if A, B belongs to R, B, C does not belong, then the relation is transitive. Is this transitive? Yes, it is transitive. If a comma b belongs to relation and b comma c does not belong to relation, then it is said to be a transitive relation. Remember this thing. This was all about the types of relations of PU2, that is 12th. Types of relation is done. Thank you for watching.